we're going to hand off to Eric. And Eric, take it away and tell us how you've been using FME and FME technology together with ArcGIS Online.
So this picture came in here, it looks like about 16, 17 minutes ago. And so I'm going to kind of walk through the entire process, what we go through. So last fall, we had an initiative to make our plow locations available to the public, so the public can get an understanding of how the Iowa Department of Transportation does snow removal and winter operations. And with that, we also had a mission to try to get images from the driver itself. So what the driver sees out there, get those to the public so the public can make better driving decisions in the winter. So we may report a road condition as partially covered. Well, the public can now see what's going on. So let me go ahead and close this off. And here's what our site looks like. And again, I'm going to run through how this works. So basically, the orange dots are plows that are active right now, running around the state. So you can click on a plow, and it'll give you some basic information, basically a timestamp, the direction of travel, the solid material rate, the liquid material rate it's putting down, the type of pre-wet weight rate, and also the number of active plows. So one of the things we were getting was the media was always asking, how many plows do we have deployed during a winter event? And they can just come now here and look at that and say 206, that goes in their news reports, and they can go on with that. And then the blue circles are pictures that come in. So these are from either supervisor vehicles or they're from the snow plows itself. So, all right. So let me kind of walk through how all this works here. All right. So how this works, we'll look at the upper left-hand corner here. The snow plows have a GPS device in there, which has multiple sensor ports on that. And so the truck gives our air temperature, road temperature, different plow states, different materials coming out the back. And that stuff, we have a vendor called LTI to Kansas City, and so we feed that data from the truck to them, and they store that in a MySQL and an Amazon Web Service. And then what we do then is we basically run what I like to call a database-centric, software-neutral approach to data here at the DOT. What that means is we try to standardize on database technologies and feed our stuff into that, and then we use tools that can leverage those environments. In this case, FME, the Esri products, the Intergraph products, that type of thing could all leverage like an Oracle spatial database or a SQL spatial database. So what happens is every minute we go make a service call, we dump that all the active plows out there over to Oracle Spatial, and that makes it so that table that we put in Oracle Spatial then gets used in the FME process. Then every 30 minutes we go back to the web service, use an FME process to grab all the pings that happened in the last 30 minutes and dump that to Oracle Spatial. And then we use that for an aggregation process. So as the storms moving across the state, we bring that data into Oracle, we use like PL SQL to then aggregate that to our sections, and so we can see over a period of half-hour chunks how much material is going down across the state, so we can be better informed about how the winter storm is approaching. So on the FME side, so basically what happens to get to our map on ArcGIS Online is we developed, well, from the plow, we have a table that's in Oracle Spatial, and then every minute we have an FME job that basically reads the active plow table inside of our database. It produces a KML and dumps it off to an Windows Azure cloud server. And then we build an ArcGIS Online map that just references that KML. And then we tell ArcGIS Online to refresh that KML every couple minutes. One of the reasons we went this way was that KML then is out there on the Azure server, and other people can leverage that at that location. What we want to get to is use FME to actually produce, insert into a feature service into ArcGIS Online. That was really, really interesting. A few of the samples you showed ahead of time that's exactly what we want to do. And so we're kind of waiting to see what 2014 is going to give us for FME, and we're using 13 now. So that's basically how all this goes. So Oracle Spatial and out to our different things. So let me go ahead and move over to what one of these looks like. It actually is pretty simple. Walk through here, we read our AVL database, read our table, we pull out some attributes, we format our date from Oracle, We use the KML property center setter. So basically, come in here and we'll set the content of the balloon and style the KML. This is where we get our icons that go on there. This is the picture one. So there's our picture icon. The truck one that we have has directional icons. So we have a tester in there that will test the bearing of the truck and then give it the right icon. And then basically what we do is we write the KML out to a directory on our FME server. And then we have another job here that is a system caller that uses AZ copy, and it basically grabs that FME file or the KML file and pushes it up through the Azure cloud, and does that, like I said, every few minutes. So let's go ahead. Yeah, go ahead.
Very impressive, Eric, and it's your architecture diagram is so fascinating to me because it shows just about every cloud service I can think of all working in unison together.
Oh, this one right here, yeah, yep. So, yeah, basically we use Oracle Spatial behind the scenes to create our winter segments, and we have our linear referencing system that uses Bentley's LDMX. Intergraph stuff rides on top of that. And the nice thing is, like on the ESRI side, we use query layers.
Yes.
So what we do is we use query layers to read that, make our map document, and then we can push those out to different things. So.
Yeah, very, very clever combination. And you mentioned also the custom app on the iPhone that takes a picture. And what was that? Whenever the vehicle is moving or standing still, I can never remember.
Oh, that's right. Yep, the custom app here. So how we get our pictures is we couldn't find an off-the-shelf solution, so we had our one of our IT teams build a custom app. So basically, what the phone does, they mount it on a. The phones come free because with a data plan, we get the free iPhone 4Ss. So they snap it in on the truck. The app will take a picture if the truck's moving more than, I believe it's either 5 or 8 miles an hour. So what we don't want to do is have the truck taking pictures if they're stopping in to get fuel, pulling in the garage, stopping on a break and things like that. So if it's moving 8 miles an hour, it sends a picture, and we have a process that runs internally here at the phone sends the picture to a server we have, and then we have a custom application. I was originally using FME, but our support team built a custom application with some extra tweaks in it that reads that picture, pulls out the data, writes that picture information to Oracle Spatial, and then pushes that picture up to the Azure cloud. So when the picture process goes for FME, it just reads that Oracle table that has all the information from that picture in it. And of course, there's also the thumbnail URL stored with that, and the full-size picture URL. And the picture then, FME process makes a KML that has the locations of the pictures in it.
Yes. And you said that the iPhone is basically like built into the truck now. It's wired right in. It's not like a loose thing.
Right. It's wired in. So basically, they've taken a charger cable, and then they've just connected it to one of the power ports. Not like the power adapter port, but they've hardwired it into the system, so the phone's basically on all the time, even when the truck is off, because it draws such a small amount of power.
Fascinating use of a phone as just a sensor, basically a connected sensor.
Yep, exactly.
Yeah.
So.
Yeah, and the result, and it's running live right there. This is where stuff's happening today.
Yep, this is live right here. So I can click on this truck over here, and as you see, we get 10:23 Central Time. I can click on a picture over here on one of our interstate systems, and you see things are pretty cleared off. So traffic's moving pretty good. Now I do have some samples from this morning. If we want to kind of take a quick peek at that, I have a few minutes left here, right?
Yeah. Let's take a peek.
Okay, so all right, so let me run through some pictures from this morning. So here again is a picture of me clicking on a blue dot. As you see here, the sun's coming up, and we're looking out there. That's what the driver's seeing. There's another example here. As you zoom in on ArcGIS Online map, we also have a feature service that shows us our stationary cameras out there.
Okay.
Again, here's another one that shows us truck putting down material. Then we get some good ones here. This is where we want to get to. So this is using a different process. We actually want to give the users real icons what the truck's doing. So in this situation right here, we have a truck here that has a wing blade down, a front blade down, and there's fire coming out the back, which means that the truck's not on fire. So what that means is the truck is actually spreading a lot of material on the road right there because it's really icy and so on. And the bars off the back give heads-up display on the rates of material coming out the back. So this is our ultimate goal for next winter, and get rid of the orange circles and give something like this to the public. So, and this is what our supervisors see on their mobile devices that they use the GeoCortex Essentials for.
Okay.
Here's another picture from this morning. This is on one of our interstates in northern Iowa. This is what it looks like. So as a traveler, you can see what's going on. Here's kind of the same area a few hours later. As you see, things are starting to get cleared off.
Yeah.
You can see all those wind turbines in the background. So,
oh yeah.
and there's that picture. I zoomed into that truck that was on fire there. So he's at an intersection. He's dropping a lot of material to make sure that people that are coming through there don't slide.
And that picture was taken in happier days, I guess.
Yes, yeah, that one was, yeah. And here's how some of our customers are using these real-time things that FME is helping us do. So here's a tweet from the middle of the night from our National Weather Service in Des Moines. So they're using the plow images to show the public what the conditions are really like out there. So again, 12:42 a.m., they showed one of our plows. They said, look, up in Mason City, which is near the Iowa-Minnesota border, that's what it looks like outside.
For a split second, I thought that the caption below it was related to the picture, Honolulu, second worst for traffic.
Oh, yeah. Apparently that's what INREX is telling us. So
yes.
So, but as you see how the news can use that. And here's another one. Here's a couple other ones here. Here's a TV station this morning showing what the conditions are like from one of our plow cams. So they're actually leveraging that information. And our own Iowa Department of Transportation will tweet out pictures from our plow cam. As you see there's that map in the background that FME is making those KMLs, and that one here is coming from our statewide 511 IA. So if you want examples of those pictures, you can go to that Twitter handle, take a look at some of the past feeds we have. So, all right. So
anyway, well, thank you so much, Eric. That is just fantastic. And yes,
that was a real-time weather radar showing the systems underneath there.
Yeah, this is Eric from Iowa DOT. Yeah, that was a real-time weather radar that comes from our very own Iowa State University's Mesonet area. So if you're interested in using that radar, they have a cache tile service you can use, and that's what this is. And it refreshes every 5 minutes on ArcGIS Online.
Oh, okay.
So Iowa State University Mesonet, MESONET, I believe.
Excellent.